So the today's video we are going to talk about the angles, whether they are scalar quantities or vector quantity. As you know that the quantities we can categorize into the two broad categories: the scalar, where they just have the magnitude, and the vectors, where they have the magnitude and the direction. As well, they also follow the parallelogram law of vector addition. So let's talk about the angles. So unlike the other quantities, we cannot categorize this angle into the just being calling it as the scalar or the vector. Like the displacement, it is a vector quantity, where the distance, it is a scalar quantity. The energy is a scalar quantity. But for the angles, we need to again categorize the angles into the two categories, where we take the large angles. It means the angles which we can measure, like 5 degree, or let's suppose the 90 degree or something like that. And the another one, we are going to talk about the infinitesimal angles, which are very small, which are close to zero. So let us first talk about these large angles. So for the large angles, I'm going to take this example. So look at this example. I have given the two scenarios, where what I'm doing is I'm rotating certain angle in the x direction and the certain angle in y direction. Now see, if it is a vector quantity, so if I write like 2ik plus 3j, and if I do the vector addition, that is going to be 3j plus 2ik. Both are going to be same. Okay, why? Because they follow the parallelogram law of vector addition. So that's why if you add two vectors like a vector and b vector, or whether you add b vector and a vector, the resultant is going to be the same. So but if I look at this, if I rotate first in the x direction and then in y direction, I will get a orientation like this in the first case. But whereas if I rotate in the y direction first and then if I rotate in the x direction, then I will get a orientation like this, where this orientation is quite different from this orientation. You can just pause the video and you can just again look at this, and maybe you can have some object in front of you, and then you can try to rotate a certain angle in that direction, in x direction and y direction, and come to the conclusion by yourself. So from here we can say that the large angles, they are not following the triangle law of vector addition, although they have the direction. It means we can say that they are the scalar quantities. The angles which can be measured, they are the scalar quantities. Now let's talk about these infinitesimal angles. So infinitesimal angles, first of all, what these angles are? These angles are very small angle. When the angle tends to be zero, then we call them as infinitesimal angles. Okay, so for that also I'm going to take this diagram. Just pause the video, try to understand this diagram, try to identify d theta 1, d theta 2 and d theta. Okay, so here I have this, the d theta 1. Let me just draw for you. So this is the d theta 1 and this one is d theta 2. The sum of these two is here the resultant d theta. So d theta, we can write it as d theta 1 plus d theta 2. Okay, if I do like this, d theta 1 and d theta 2, if I add like this, then the resultant is like this. First if I add d theta 1, then if I add d theta 2. If I add the d theta 2 first, or the d theta 1 first and then the 2, so then the resultant still is the same. The another way to understand is, see, d theta can be written down as ds times of r. Okay, or sorry, the displacement ds can be written down as d theta times of r. Now because the small angles, if they are very small angles, so then this displacement can be considered as a straight line. So this is the straight line, a small angle ds1, and because of that there is a displacement ds1, and because of this angle ds2, d theta 2, there is a this displacement ds2. The resultant of these two is somewhere like this. And because the displacement is a vector quantity, so of course their addition if we do, so that is going to be a vector quantity. So that's why I can say ds1 plus ds2. All right, so what happens in case of the small angles? The whatever the displacement is going to come, that is a straight line, and because we can just add the displacements, and that is why we can also add the angles, and that is why whether you add the angle d theta 1 plus d theta 2 or otherwise you do the d theta 2 plus d theta 1, you are going to have the same result. And because of that we can say that the infinitesimal angles, they are the vector quantity. And if the infinitesimal angles, they are the vector quantity, then the rate of change of these infinitesimal angles are also going to be the vector quantity. So rate of change of that is the angular velocity. So angular velocity is a vector quantity, and the angular acceleration, that is the rate of change of the angular velocity, that is also a vector quantity. All right, so I hope you must have understood this, why we call these infinitesimal angle as vector quantities, whereas the large angles, they are the scalar quantities. So if you have the doubt in any other topic, you can just ask in the comment section. And if you want to watch other videos, these videos are available on the channel. You can just watch the other videos, and you can share this with your friends. Thank you.